Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ukobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so question 7 says a research satellite has a mass of 3.4 times 10 to the exponent of 3 kg. It orbits the Earth at a distance of 2.32 times 10 to the exponent of 6 meters from the center of the Earth. Now we can see that the confirmation of the distance that we are supposed to use is there because it's from the center of the Earth, right? So remember, the distance that we are considering is from the center of the Earth, which has a mass of 5.98 times 10 to the exponent of 24 kg. So this is the mass of the Earth. Even if you were to check it on your data sheet, you know that's the number that appears for the mass of the Earth. Now 7.1 says calculate the gravitational force that the Earth exerts on the satellite. So to calculate that, we know the formula that we use is F is equals to G m1 m2 over r square, right? Now we know that G is the universal gravitational acceleration constant, and then it is also found in your data sheet, so you can check it out from there. So you do not really have to memorize anything when it comes to this. And then we have the mass of the satellite, then we're going to multiply it with the mass of the Earth, right? So there we go. Then all that over the distance in between the satellite and the Earth. So we have it like that. So this was just a matter of knowing which formula to use and then simply just substituting into that given formula. Then you punch into your calculator. Nothing hard about that one. So 251,959.05 newtons rounded off to 2 decimal places, right? So we have it like that. Or if you used the scientific method, then you were supposed to have the 2.52 times 10 to the exponent of 5 newtons, right? So this is if you left your calculator in normal form, and this is if you change your calculator to scientific form, right? So both these answers are acceptable. Then we have 7.2. Name and state the law that is applicable to this situation. You say it's Newton's law of universal gravitation. So you get a mark for that. And then having to define, that's 2 marks. So the definition says every body attracts every other body with a gravitational force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So note here, you say between their centers, and then 2 marks for having to define, right? So all in all, that's your 3 marks. Okay, then we have 7.3. It says another satellite of mass half that of the research satellite orbits at a distance half that of the research satellite, right? Then that means they're halving the mass, and then they're also halving the distance. Okay, and then from the center of the Earth, calculate the magnitude of the force of attraction between the Earth and the satellite. So how you solve this question, it's this way, right? So you don't have to come here and try to divide this one by 2 and also divide that one by 2. There is a way in which you can calculate that using the format of F nu. So if we wanted to figure out what is our F nu, first we would have to write the formula, which is F is equals to G m1 m2 over r squared. And then now we write F nu and kind of do whatever that they told us to do. So G, we have first the halving of this mass here. So it's half m1. Then they did not do anything to the mass of the Earth, so we'll just keep it m2. But then again, they said they halved the distance. So what we do is we'll say half r and then square that. Right, so in the position of r, remember, we are saying this is half of r now. So what we want to have now is that this will be half G m1 m2, and then below here we'll have 1 over 4 r squared. But then if you can remember, this whole part here, this can be replaced by f, right? Because f is equals to all of this. So this part here can be replaced by f, and then we can just punch these ones in the calculator and just go, what is 1 over 2 divided by 1 over 4? Now, if we do that, we will find our value as 2. So that means that's twice f, meaning that what happened if we decide to have the mass of the satellite and also have the distance between the satellite and the Earth, what we will find is that we will have twice the gravitational force, right? So we'll have twice the force of attraction between the Earth and the satellite. So that's what we deduce from here. So halving the mass and halving the distance results in us having twice the force of attraction. And then therefore, to calculate our F nu, we'll say 2 multiplied by the value that we got from the previous question, which was 251,959.05, right? And then if we have to multiply by that, then we will find our new force of attraction or gravitational force, which will be twice the one that we calculated from before. So let's quickly punch that into our calculator. 503,918.1, right, newtons. That's how you were supposed to do that. And then if you had calculated, or if you had used the one that was in scientific form, obviously, you were going to have 2.52 times 10 to the exponent of 5. And then if you multiply the 2, then you are going to have 5.04 times 10 to the exponent of 5 newtons, right? So it's just a matter of whether you used the one that was in normal form or you used the one that was scientific. So note. So these are for the ones with calculator in normal, and this is for the one with the calculator in scientific. Okay, so that's how you were supposed to go about answering this question, all for a total mark of 10. So I hope that makes sense. So with all that being said, if you've enjoyed the lesson, please press the thumbs up button. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.